Hi guys, myself here Sachari from CSS section. In this video we will discuss about Lotus SQL. It is an SQL engine for high performance big data. Topics: Introduction, Lotus SQL, Conclusion. Introduction. In recent years, Apache Spark has become the standard for big data processing. Spark SQL is a module offering support for relational analysis on Spark with structured query language SQL. Despite its efficient optimizer, Spark SQL still suffers from the inefficiency of Spark resulting from Java virtual machine and the unnecessary data sterilization and desterilization. Lotus SQL implements a set of structured datasets operations with high efficiency and integrates them with front-end. Evaluation results show that Lotus SQL achieves a speed of up to 9 in a certain queries and outperforms Spark SQL in a standard query benchmark by more than 2 on average. Lotus SQL is a single mission data parallel computing engine by a low overhead storage module and a high efficient compute model. The storage module is designed to have a low overhead on the basis of a combination of buffer caches and compact object models. The compute model is a C++ dataset programming model. Lotus datasets provides the abstraction of compact collections and efficient operation implementations. Lotus dataset is a logical and array of records that is segmented into a multiple operations. Except for distributed allocations, its abstraction is quite similar to Spark's RDD. It also adopts a lazy evaluation strategy and supports fault tolerance. All intermediate results datasets can be cached explicitly. However, as a C++ dataset, it employs compact object storage rather than the general object storage to reduce sterilization and desterilization overhead. Lotus dataset supports primary data types including hint, double, and string. For a string dataset, the data are organized in two compact buffers, one as indexes and another as original characters. Lotus provides a complete engine for Lotus SQL. We add structured dataset abstraction on Lotus and connect it with SQL. The processing starts from SQL queries and ending at actual execution. Results can be divided into four parts. First, an SQL query is taken and partitioned into a logical plan with schema information. Second, a series of optimizations are conducted to generate the physical plan. Third, the physical plan is mapped into C++ codes of structured data operations by the code generator. Finally, the codes are run on Lotus and correspondingly results are obtained. In the following parts of session, we future describe the process in detail. In this picture, we will see the workflow of an SQL, Lotus SQL. Select start from and it will press with schema. Then it will execute plan optimization with logical plan, supplement, optimizer, cost model, physical plan. Next it generates the code generator after structured dataset Lotus SQL, then run. Since the introduction of Google file system and MapReduce model, big data processing based on their ideas has grown rapidly. Hadoop and its file system supports fault-tolerant MapReduce workloads on large clusters. Twister and Hadoop improves iterative MapReduce workloads by keeping invariant data between iterations. Spark Future supports persisting data in memory to enhance data reuse. Another contribution of Spark is the abstraction RDD and its consequence interfaces. SQL for big data systems. On the top of these systems, the need of OLAP on structured and semi-structured data encourages many specific modules or subsystems. Pig, Hive, and Impal are query language engines for Adobe supporting SQL or SQL language. Pig and Hive are developed in Java using integrated with native Adobe, while Impala uses C++ and does not build on MapReduce. However, Impala lacks some important features such as correlated subqueries and custom used functions. Shark and Spark SQLs or SQL engines. For Spark adopts a completely new query optimizer and is widely used because of its complete functionality and energetic community. Compute time. We evaluate the average query time of Spark SQL when the maximum memory for the whole Spark culture is limited to 96, 128 or 512 GB. Spark SQL involves external storage and data shuffling when the memory is insufficient. The performance degradation caused by external storage access mostly happens before 256 GB. We also try to limit Spark SQL memory usage to 64 GB. However, many queries fail because of insufficient memory under this constraint. Thus, we discrete the configuration. The comparison of each query is presented in figures. The average maximum memory usage of 22 queries is 153, and which is about of 1 is to 5 original tables. But some of the complex queries, the memory is still relatively large, which is reflected by a red triangle appearing at the right side of sub-figure. The sub-figures of Q9 and Q18. Lotus adopts a partition-wise computing model that each thread loads a partition into the memory at a time. Therefore, parting tables in smaller pieces can save money, memory, and it's possible to run on a mission with less memory. SQL support in system hierarchy. Although Lotus SQL says it has SQL module for the Lotus system, it actually for Lotus operations. Calstri leaves the storage management that backend provides adapter to connect to them. Lotus can replace in memory storage module with a distributed one transparently. We will analyze the distributed version in the future. For Lotus, such a adjustment is not needed because our cost model is not fine-grained and our physical operations keep the relative cost in distributed mode. This is the system hierarchy. SQL Pricer optimizers physical plan. The SQL Pricer and optimizer are the front end and back end is the dataset API, operation, implementation, IO, storage, scheduling. Conclusion. Modern data analysts need to make efficient use of modern hardware with a large memory and numerous cores. To boost Lotus with a convenient and expressive user interface, we present Lotus SQL. The dependencies are resolved as a whole and compressed during C++ compilation time. In future Lotus SQL versions, we plan to support prepared statements in SQL queries to enable query plan reuse and to improve the optimization towards correlated subqueries. Thank you.